Andrea Gibbs.
On ABC Radio.
From the air, it's not much to look at. Sure, it's big, but to the untrained eye, you'd look out of a plane window and you'd go, bit of a dip in the landscape. But to the trained eye, that dip in the landscape was a sign of something much bigger and cataclysmic. The Yarrabubba crater was discovered some time ago, but West Australian scientists have been working hard to unlock its secrets, and this week they published their findings. I think it's fair to say that Curtin University Senior Research Fellow Dr. Aaron Kavosi is pretty excited, but before we unleash all of that, let's get some background. Dr. Kavosi, can you describe what this crater looks like?
Sure, my pleasure. It's the outback of WA. So, in one sense, it's a barren landscape, but it's full of geological richness and a long geological history. As you drive north of Perth and you start to approach Meekatharra from the south, it's a broad expanse of red desert. It's sandy with bits of rock cropping out here and there. What you don't see is a giant, big, bowl-shaped hole in the ground. This crater formed so long ago, it has been eroded very deeply, and so you don't see the circular ring of mountains that would have existed when it first formed. You have to look a little more carefully to see it today.
How wide are we talking, this bowl?
When it formed, it would have been a feature that was 70 kilometers across. You could have picked up Perth and chucked it right in the middle of it. It's giant. This thing would have been a monster. It would have just unleashed geologic violence and carnage on the landscape. It truly would have been a cataclysmic event. How
long have we known about it?
Well, that's just it. You know, science is typically not all done in one fell swoop. This particular site, Yarrabubba, was first described in the scientific literature nearly 20 years ago when some very careful studies were done that did the initial important documentation of the small-scale features that show this truly is an impact site. The thing is, at the time, they didn't have accurate or reliable means to date this feature, and so its age remained unknown.
Yeah, and this is what you guys have found in your finding. It's big news, its age. How old is it?
Well, listen, you know, at Curtin, we have a big group of crater hunters that work all over the world, and we're interested in craters that are known about and also finding new ones, and so we work on a lot of different sites. One of the things that we always are interested in trying to establish is the age. In terms of geological whodunits, we need to know when it happened. And so that was one of the driving motivations to investigate Yarrabubba. And the way we worked that out was to look for small minerals, tiny little grains, inside rocks that had been severely damaged and melted from right at the center of what remains. And in those little grains, we found the telltale signs of the cosmic damage, and we knew that those particular grains would record the age of when it formed. And we took those grains back to the laboratory, and they all yielded the consistent age of 2.229 billion years ago. And that's when we just had to step back, because we had no idea this would end up being the oldest impact structure ever found.
What about the second oldest? How much older is this one in the Yarrabubba crater?
A lot. Prior to this discovery, for almost 25 years, the oldest impact strike known has been in South Africa at a famous World Heritage site called the Fredefort Dome impact structure. It's about an hour south of Joburg, and it's a spectacular place to visit. And so the interesting thing is that site is right bang on at 2.02 billion. And even though this has long been recognized as the oldest asteroid strike on Earth, it's still pretty young. That's less than half of the age of Earth, which is astonishing because the first part of Earth's history would have involved a lot more asteroid strikes. With Yarrabubba discovery, we've pushed the goalpost back more than 200 million years, and for geology, that's a lot. That's a big step back.
Yeah, to give us all some context on that, what's the timeline between the Yarrabubba and the dinosaur extinction event?
Yeah. The dinosaur killer was an asteroid strike that occurred in what's now the Gulf of Mexico, kind of geologically yesterday. That was only 65 million with an M years ago. We compare and contrast that to Yarrabubba. This is 2.23 billion with a B years ago. So the dinosaurs didn't come on the scene for billions of years after the Yarrabubba strike. So this is a very different, very much further back event in Earth's history.
What was the Earth like 2.3 billion years ago?
Well, that's what's really fascinating. The farther you go back in time to explore the geological record, the trickier it is. It's no less than forensic science on an Earth scale to try to recreate the history of events because the geological record isn't complete. There's a lot of holes in it. When we established the age of this asteroid strike at 2.229 billion years ago, we realized very quickly that coincided with another major climactic change on Earth, and that is the disappearance of ancient glacial deposits at that time. Now, the glacial deposits that are known and had been known about before had fascinated scientists and led to discussion about what was the trigger, what was the mechanism to make these glacial deposits disappear, because they're gone in the geological record for about 500 million years after that time. So when we found that the Yarrabubba impact age coincided incredibly overlapping the age of the disappearance of these glacial deposits, we said, well, geez, could it possibly be that this impact triggered a warming event that could have caused the Earth to come out of an ancient ice age? And that is just a phenomenal thing to think about, that a rock from space could have changed the climate so dramatically to basically change the history of the evolution of the Earth.
So Meekatharra, right out there kind of in the middle of nowhere, would have been covered in really thick ice. The
thing is, in science, you rarely get the full picture. You have to put it together. In this case, the evidence of ice at that time is over in South Africa, and we don't precisely know what latitude the asteroid strike was at the time. Because it's so deeply eroded, we don't have evidence that ice was at that site, but we do have evidence for glaciers on Earth at that time that some think were widespread. So we posed a question at that point and said, well, let's evaluate what the effects of a strike of this size would have been on an ice-covered planet. And so we ran computer models that varied the thickness of an ice sheet between about 2 and 5 kilometers, which overlaps with the ice sheet thicknesses today in both Greenland and Antarctica. And we found that a tremendous amount of water vapor gets ejected into the atmosphere. The thing about water vapor is it's a greenhouse gas. And so injecting a lot of water vapor can increase the greenhouse gas content, and then that can trigger some warming. There's a lot of things we don't know, to be very clear. The longer the water vapor stays in the atmosphere, the worse the effect is, and we don't know how long water vapor would have stayed after Yarrabubba. We don't know how much ice it might have hit. So there's uncertainties that, for science, they kind of provide a roadmap of things that you can test going forward. But the great result is we've laid out a hypothesis that is just absolutely fantastic, and we have some ideas to test going forward.
From one massive 70-kilometre wide hole, it's created a whole bunch of other little holes in the world of science to be filled up with knowledge. In terms of your career, I love that you call yourself a crater hunter, is this a career highlight for you?
Oh, this is a once-in-a-generation type discovery. There's no doubt about that. As I mentioned before with the site in South Africa, that was established almost 25 years ago, and there has been no other discovery of an older crater until this week. And so it's just an absolutely fabulous discovery to be involved with, and to have the site actually coincidentally be in Western Australia. Like, are you kidding me? The geological history here in Australia broadly, but certainly in the West, is astounding. Some of the oldest forms of life ever found on the planet are preserved as stromatolites up in the Pilbara area that go back about 3.4 billion years. Even older in the Jack Hills of WA, they contain the oldest minerals on planet Earth back to 4.4 billion years. And now to this list of just absolutely stunning geological heritage, we add the world's oldest meteorite strike. I mean, that's just amazing.
I can detect an accent there in your voice. Have you made it to Crater Heaven?
We've been on Crater Cloud 9 for some time now. It's just astonishing when you're sitting there on an instrument and an age rolls off, and you see the age and you can't believe it, and you assume that it must be in air. Let's do another spot. And the next spot comes back and it's the same number, and the next spot comes back and it's the same number, and you double check the data and it all checks out and it's reproducible. It's just the gold standard. It's amazing.
You're on cloud nine at the moment. It's a career highlight for you. Is it all downhill from now?
Absolutely not. We're just beginning to pose new questions that are going to take us to brand new heights. I mean, the discoveries like this, they establish a new benchmark, and from there, you go further. For instance, there's a lot of sites that are suspect craters where people think there might be an impact that had occurred there, but the detailed work has not been done yet. Even in cases like Yarrabubba, this was a known site. I mean, people had driven through this on the road south of Meekatharra every day for 20 years, and with no one thinking twice or looking at the rocks around. And so there's a whole bunch of amazing discoveries right under our nose waiting to be made. And so it's just an exciting time.
Dr. Aaron Cavosi, crater hunter and senior research fellow at Curtin University. Thank you so much for your time today.
My pleasure.